In this session, we will discuss about zeroth law of thermodynamics. What the zeroth law of thermodynamics says: when two systems are individually in thermal equilibrium with a third system, then those two systems are said to be in thermal equilibrium with each other. That means, consider a system 1 and consider another system 2. If these two systems are in thermal equilibrium with a third system, then these two systems are said to be in thermal equilibrium with each other. Or in other words, you can say that all the three systems are in thermal equilibrium with each other. This zeroth law of thermodynamics provides a basis for the temperature measurement. Consider a cup of hot coffee at a temperature of 80 degrees Celsius. Now take a thermometer. Look at the thermometer. It shows a reading of 37 degrees Celsius. Now, if I measure the temperature of this hot coffee, it will show 80 degrees Celsius. I keep the hot coffee in a room for 10 to 15 minutes. After that, again I check the temperature of the hot coffee with the thermometer. That time it shows only 37 degrees Celsius. What has happened during these 10 to 15 minutes? The hot coffee has lost its heat to the surroundings. The surrounding temperature was 37 degrees Celsius, and now also the temperature of the surrounding is 37 degrees Celsius. So from this it is clear that if you consider this as one system and this as another system and the surrounding as a third system, if these two systems are in thermal equilibrium with a third system, the surroundings, then all the three systems are said to be in equilibrium with each other. Now let us discuss how this temperature can be measured. The measurement of temperature is generally carried out with the help of the temperature scale. Temperature scale is nothing but is a quantitative measure of the temperature of the system. Before 1954, there were only measurement of 2 points. One is an ice point and another one is steam point. Let us consider Ti is the temperature at the ice point of property Xi, and Ts is the temperature at the steam point of property Xs. The temperature at any point is a linear relation which is given by T is equal to Ax plus B. Now, the temperature at the ice point can be written as Ti is equal to Axi plus B. Temperature at the steam point can be written as Axs plus B. Let this be our equation 1 and let this be our equation 2. Solving these two equations, we obtain the constants A is equal to Ts minus Ti by Xs minus Xi and Ti minus Ts minus Ti by Xs minus Xi multiplied with Xi. We know that temperature T is equal to Ax plus B. Plug the values of A and B in this equation, we obtain T is equal to Ti plus Ts minus Ti into X minus Xi by Xs minus Xi. There are two scales for the measurement of temperature. One is Celsius scale or centigrade scale and another one is Fahrenheit scale. Let us discuss about the centigrade scale. Let Ta is the temperature at the ice point, which is 0 degrees Celsius, and Ts is the temperature at the steam point, which is 100 degrees Celsius. This is ice point or freezing point. This is steam point or boiling point. To find the temperature T, we use this equation. T is equal to Ti plus Ts minus Ti into X minus Xi by Xs minus Xi. With the values of the temperature at the ice point and steam point, we obtain T is equal to 100 into X minus Xi by Xs minus Xi. Now coming to the Fahrenheit scale. Let the temperature Ti be the temperature at the ice point. In Fahrenheit scale, it is 32 degree Fahrenheit. Temperature at the steam point is 205. Now the temperature relation is Ti plus Ts minus Ti into X minus Xi by Xs minus Xi. Plug the values of temperature at the ice point and steam point in this equation. We get T degree Fahrenheit is equal to 32 plus 180 into X minus Xi by Xs minus Xi. Now let us Briefly discuss about the relation between the Celsius scale and the Fahrenheit scale. Temperature T is equal to 100 into x minus xi by xs minus xi in centigrade scale or Celsius scale. In Fahrenheit scale, it is 32 plus 180 into x minus xi by xs minus xi. This equation, temperature scale in degree Celsius, can be written as T degree Celsius divided by 100 is equal to x minus xi by xs minus xi. Plugging this value of x minus xi by xs minus xi in this equation, we obtain T degree Fahrenheit is equal to 32 plus 180 into T degree Celsius by 100. Simplifying this, we obtain T degree Fahrenheit is equal to 3.2 plus 1.8 into T degree Celsius. This is how the temperature scale of degree Celsius and Fahrenheit can be related. Thank you.